Hello, friends. Good afternoon. Good afternoon to everybody. It is almost 8 and we are here. So, we'll be discussing about time. Some people have already joined. Thank you all. It is almost 8. We'll be starting our discussion on what is time. So, once again, a very good afternoon to all. So, when we talk about time, we first say that time is one of the most least understood thing in physics. Time is not properly understood right now, and still debates are going on everywhere till now that what really time is. We start with Aristotelian and Newtonian concepts. So, what did Aristotle say about time? For Aristotle, time was like something which is a measure of change. Something which is a measure of change. That means, in Aristotelian sense, if nothing is changing, so there is no time. If something is changing, and that change actually we conceived, we imagine that change as time. We see that change as time. So if there is a change, there is a time. If there is no change, there is no time. That is for Aristotle. When we come to Newtonian world, Newton actually told that time is, there is something universal about time. So time is not really a very relative thing as Aristotle have imagined. So time is something that there is an universal flow of time. So whatever in Newtonian world, that world was very flat. We know that. So in a common Newtonian mechanics, there is a time. There is a universal time which we cannot measure very precisely because of inaccuracy of the clocks. But okay, it is still there is an universal time. There is an universal present. There was an universal past, and there will be an universal future. So for Newton, the world has a configuration, exact present, exact configuration. These were a very classical Newtonian concept. That we do have a present, exact present. That means that now, if I say that what is now, we'll imagine that okay, now at this point of time, Jahid Saz is talking about something, we are watching about something, there is my mother is doing something, the Trump is doing something. So that our common perspective of uniform time or uniform structure, or I say uniform configuration, that past, present and future, each and every configuration do exist. But in Einstein world, things began to change once again. How? That is my first topic of discussion in this first episode. That how did Einsteinian concept changed the Aristotelian and Newtonian concept of time? Okay, let's start with what Einstein told you. Einstein started from Maxwell's equation. He didn't discover or invent the theory of relativity from nothing or from zero. So in Einstein's concept of time, time is relative. That you already understand. That if something is going in a large speed, the time changes there in a different way, then time changes in your space. Let's say we are in Earth, and something is moving in a large velocity. You might have read this. Let's say something is moving speed with similar to the speed of light. That's there in his frame or her frame, time changes in a different way. Someone travels, say, with half of the speed of light, and goes in some outer space for 1 year and comes back. It might be possible that 5 years or 10 years have been passed in Earth, and that spaceship experienced just 1 year of time. This is usually, we call it time dilation. So the moral of the story is time passes differently. So changes happens differently in different places. So why, sir, you told places? You are talking about speeds, right? Yes, that was first calculated as special theory of relativity, that time indeed depends on speed. The change of time, let's say the change. Whenever I say time, it is to be understood that change, delta t, that separation between two events. That is, we define time. Let's say I started this live before some time, and right now I am talking. So when I press the button live, go live here, and right now I am talking, this is two events. So we have a time separation between these two events. So he always deals about two events. So okay, so the separation between the two events in two different frames are different. So when something is moving very fast, so the time there is changing in a different way than something which is at rest. Say, there is no absolute rest. Everything is relative. So then slowly your concept becomes jumbling about. Okay, let's forget about all the speeds and etc. Just imagine in Earth. So in Earth, somebody is in a mountain, top of mountain. So you are in above Mount Everest, and I am here in Kolkata, Jadavpur. Time changes differently in these two places also. That is very, you might not believe it, but it's true that time changes differently in different places, in different heights. Why is it so? Then comes the second part, mass, acceleration, space. All these things are correlated, which was apparently not related. Mass and time was not related in Newtonian world. But Einstein showed that if something is massive, if you are near to some mass, your time passes slowly. So if you are at flat here in a plane at Kolkata, your times pass little bit slowly than someone who are in Mount Everest, or someone is in someone in outer space beyond, say, 50 kilometers above Earth, or 1000s or millions of kilometers from Earth. Its time passes a little bit slowly. If you are near sun, so you're near a heavier mass, your time passes slowly. And if you are in outer space, your time passes a little bit faster. So I did a mistake. I just corrected. If you are near some mass, your time passes slow. So what happens if you are near a very heavy mass? say near a black hole, your time passes very, very slowly. And if you are inside a black hole, your time essentially stops. Here, once again, the Aristotelian idea resurfaces. Aristotle was not entirely wrong. If you imagine, time is just nothing but a sense of change, so then if you are inside a black hole, you don't see anything. No light and no information goes inside a black hole. And in general, a black hole is just a single state. So time changes almost zero inside a black hole. What about the time from the perspective of a photon? Photon is moving light. Imagine light. Light is flowing in the speed of light. Does light experiences any time? Say somehow if you or me is traveling in speed of light, does light, or when we move in speed of light, is it not possible because we do have a mass? But if, say, imagine yourself moving at speed of light, do you experience this time then? Do you see anything then? No. Because if you are moving at speed of light, nothing comes to your eye. You see absolutely nothing. You don't have any time then also. So it is a simple physics, simple imagination, very simple consequences of special and general relativity, which actually tells us two very strange things. What two strange things? If we are inside a black hole, we don't see any change. So we don't experience time at all. Inside black hole, time stops. And from the perspective of photon itself, nothing changes. No time. There is no. So what we already learned somehow, we mostly physics students there, so we already learned somewhere that in our special relativity course that time is relative. And that relative time-space spans from black hole to light. So now the next question is it possible that essentially time is an illusion? There is no time at all. We'll discuss about later. That perspective is important. One more question is, when we discuss about time, we always see that time flows from past to present to future. So there is an arrow of time. Why is it so? Is it something related to entropy or possibilities or configurations or informations? We'll discuss this also. There is another point to be considered, to be thought about, that does time started at the point of Big Bang, as really time started at that time? Time really started at that time, or rather I say, did time really started at that event, at the event of Big Bang? Then you ask me a question that if time is relative, if time is not absolute as Newton thought about, if time is relative, then why should we think about some point or some event where time is started? Time is very relative, so there is no absolute time. So these questions we will discuss about throughout this lecture series. I will try to take 3, 4, 5 or whatever I can do. So let's see, let's forget all about and start afresh. So what we learned? Time is relative. Time flows in different pattern, different ways, in different places. Mass has a very essential role to play here. If you ask me in a very deep fundamental way, why mass actually changes the flow of time, I would say that I don't know. I know what in general physics structure says, but I don't comprehend that part. And I believe that we don't actually properly understand what mass is. For me, mass is nothing but a concentrated form of energy. And what energy? That light energy. And what is light? Light is our beginning of energy in the universe. So if we take our Big Bang to be true, so the first expression of our universe, or first existence of our universe, was manifested in terms of light. Whenever I say light, I say electromagnetic wave. So light is a most fundamental energy of universe. And I say mass is concentrated form of that energy. So it's a localized form of light. If you release mass, if you release that concentrated form, so that becomes light and that becomes timeless, then it experiences nothing. And when light becomes concentrated and become mass, it experiences time, and it rather cause the time to get slower, slower and slower. Mass makes change slow, and mass is concentrated light, and normal light is released light, unconcentrated or delocalized light. So I think that way of imagination gets us little bit of, say, philosophical thoughts in our mind, but not in terms of mathematical equations. So as you might have already read, that there is something about space-time. So space and time are not independent. Mass and time are not independent. Everything's are related. How space and time related? As we see, say two events happening simultaneously here. Say I just get, say, these two events I perform simultaneously in my frame. But someone might see that I performed my right hand chutki at some point and left hand chutki after some time. So somebody might see that there is a gap between these two events. So as we see, the space and time, there is no distinction between them. I know I'm unable to make you properly understand, but I'll try to do in the latter classes. So space and time are fundamentally related. And lastly, I would try to try to tell you about the configuration. What is present? Is present defined properly? If I say right now, I am telling you some words and you are hearing it, that is our localized present. In Earth, we formed our surrounding space, and here our time gap is very, very less. So that's why it is quite okay to deal with the present. But if I say, what is Cyrus doing now, right now? Cyrus is a star. Or what is Milky Way doing now? Or say one of our friend is at some star, say 1 light year away in a star. Can you say that what is that friend is doing at that star right now? Or if you say a little bit more easily, that what is our sun, what is happening inside sun right now? Firstly you will tell that, okay sir, we cannot tell because the information what sun is doing comes 8 minutes later. But that is one way of thinking, that light comes from sun 8 minutes later. So whatever we are watching right now at sun, it is actually a 8 minute prior state of sun. That is okay. That is information comes from sun a little bit. It takes a little bit of time. But is it properly defined that what is the sun doing now? If you think very deeply, I think you might understand at some point of time that the present configuration, the imagination of present configuration, actually does not exist. So actually present does not exist. In a simple class, or a simple say in a very simple discussion, it is not very easy to make you all understand. But actually that concept of configuration does not exist. Sir, is causality exist? Something causing something. Say if I make here a slap, I feel a little bit of pain. So that cause and effect relation is there. So as per 2024, the causality relation still exists. Something causing and something happening. But there is no universal frame or universal configuration where all those things are actually happening. So what do we understand from here? We understand that we inside Earth, or say near about Earth, we do have our own sphere of experiences where the flow of time is passing almost uniformly, and that experiences us no difference between my flow of change and yours flow of change. So it's our imaginary sphere of influence of of almost similar pace of flowing of time, and that is our present configuration. We live in a present configuration and in a present experiences that I am experiencing, that I am similar to yours, and that's why we make a society, a friendship, and a structure a civilization. That configuration exists. But as we imagine things further and further away from us, that configuration, the imagining actually a present thing, that if something is present configuration, that does not exist. Okay, I think I'm going too far away. So I once again comes back to our basic discussion topic, that from Einstein perspective, the time was relative. And there is a theory which Einstein actually were inclined to support, but that theory was not properly developed at Einstein's time, and that theory still questions. That's the block universe theory, where we actually tells that time is a proper illusion. The past, the present, and the future actually happening at exact same time. So it's like a static configuration. Einstein once actually told that past, present, and future, everything are an illusion, and that sentence actually quoted in the famous Netflix series of Dark. If you have not watched Dark, you can watch it. It's a strong recommendation from me. So okay, and if we say that okay, time is an illusion, past, present, and future, everything is happening at same time, or same configuration at exact moment, these are all static configurations. So then what next comes is a deterministic idea. So then everything is fixed. We don't have free will, right? If we believe that time is an illusion, so then we also need to believe that whatever will happen is exactly fixed. So, but as we see, our conscious mind never accept that theory. We always see that we ourselves, say myself, Jahid sir, you are someone else, we can do something by our own power. That is our consciousness, that is our ego, right? So exact deterministic universe theory has some problem with our common consciousness. We are not willing to believe that that we can do absolutely nothing. So here the quantum world comes, the quantum world, the quantum fabric of time and quantum fabric of happening is actually full of possibilities. Here's come the randomness thing, that we don't know which atom will disintegrate. Say I am talking about radioactivity. If you have bunch of uranium, say, or plutonium, we know that some uranium, some plutonium will disintegrate, but we don't know exact what time and which uranium atom will disintegrate. There comes the random events of quantum. And actually, as you will learn, that quantum world has a very fundamental conflict with this Einstein world. And as far as we understand right now, that both quantum mechanics and the whole special and general theory of relativity of Einstein, the world of Einstein and world of Niels Bohr, cannot be true, both together. If we have to say that Einstein was 100% true, then Bohr quantum world is wrong, essentially. And if quantum is 100% true, accurate, then Einstein is essentially wrong. But that debate is not been solved till date. So, quantum world actually leads us to indeterministic philosophy. Quantum world always say nothing is predetermined. Everything, the world is full of possibilities, and that's our conscious mind wants to believe. And Einstein world, Einstein theory slowly actually leads us to that point where we need to accept that everything is deterministic. So deterministic world or indeterministic world, deterministic change and indeterministic change. This is of very, very fundamental conflict, fundamentally contradictory domains of physics. That will be the better choice of word. That these two domains are very, very, very fundamentally contradictory. So time is relative in Einstein's world, and that fabric of space-time goes slowly, pushes us to determinism. So okay, now once again going back to black hole. What happens inside a black hole? You don't see anything, so your heartbeat also stops, and you does not exist as a form of our, say, in a physical body. We cannot exist because in physical body our heart need to beat and our blood need to be flowed. So that might not be possible there, is it? Or in your proper time or in your frame everything can change, but you cannot see anything from outside. That debate is still to be solved. What happens to singularity? Black hole do have kind of singularity. What does it mean by singularity? Singularity is essentially when something diverges. You don't need to be worried about but black hole is very massive, so everything is very dense there. So there is an infinite, almost not infinite exactly, black hole do have a size, but a very large density is there, and some infinity types of things comes when you do try to solve your mathematical equations. So there is some problem when you do really try to solve mathematical equations inside a black hole, or something prior to Big Bang or at very exact time of Big Bang. So there your delta t essentially stopped. So what I wanted to do in this lecture is to create some questions in your mind, and in a very popular level. You might not have read any much physics, so you might be a school student, or you might be anyone outside the domain of physics. So that is not a problem. But essentially what I want you to understand, that time is something which we don't understand properly. That is the first thing you should understand. Second is, time flows, or the change flows in a different ways, in different frames. Time flows slowly when something is speeding up. Time flows slowly when something is near a heavy mass. So mass slows time. Light does not experiences time. Inside black hole, nothing experiences time. So that Aristotelian concept of time is a measure of change is still very valid and very relevant. Thirdly, I want you to understand that past, present, and future might be an illusion. The world might be completely deterministic. There might not be a free will at all from Einstein's perspective. It is not mathematically proved still now, but can be. It can be. And what else we will need to understand? We need to understand the arrow of time, the flow of time, how time flows, why time flows in a unidirectional way. And entropy. If you have watched Tenet, the Christopher Nolan movie, so you might be very interested about the relation of entropy and time, the time flowing in a unidirection, or time can be flowed backward. So these are the things we'll discuss more. And I will also want to discuss about the Big Bang and that cycles of time. There is if there is a chance that the universe is still eternal, as Roger Penrose, the Nobel laureate physicist, do think that there is something beyond the Big Bang also, and the universe essentially eternal, and just one universe need not to be destroyed. So these are very interesting ideas I will like to discuss in the latter part. Not today, say episode 2 or episode 3. So friends, I think should we make it a day right now? Time travel, I don't know, Lalu, possible or impossible. Einstein equation does not make time travel possible, but well, physics still not stopped, so time travel still not possible from the physics as far as we know today. Time travel is not possible. You can go to the future. If you travel very higher speed for 1-2 years, you might end up 100 years later in Earth, but you cannot come back here. So that I don't say time travel. Using time dilation, you can slow your time and go back to and come back to future. You can go to a very massive star, near very massive star, and come back, and you spend 1 year near a very massive on a massive planet, on a massive Earth, and in your Earth, the time might be 100 years. So in that way, you can go to the future, but you cannot come back to past. So, and if you want to ask, sir, what about the concept of wormholes and etc., as time travel, as we see in Dr. Strange movies and Marvel movies, these are all imaginations. We don't have anything. I don't have to say anything about all this. These are all just an imagination and science fiction tales. So if you want to ask me anything, you can write in the chat box. I am reading everything, so I can read your messages. So if you want to ask anyone, if you want to ask anything about any questions about this relativity, time, and etc., anything about Big Bang or time travel, as Lalu said, you can ask me anything. What I plan till I am done here. That this much I wanted to tell. Just to start, just to make you guys thinking, because academics progresses when somebody thinks. So if you think about many things in your own way, then actually academics progresses, science progresses. I think in my own way, you will think in your own way, then science will slowly progress. Light does not experiences time, Subhash. I already told you once that light does not experience time. If somehow your consciousness flows with time, you will experience nothing. You will become light. So I will once again repeat, light, we don't understand actually what light is. Light must have much deeper, much deeper meaning in universe, right? Is as we understand it is just electromagnetic wave, solution of Maxwell's equation. But light is essentially structured with very core fabric of space, time, universe, Big Bang creation, consciousness. Light is at the very core of that. Time does not make any sense to light. That's right, Shubhas. You are thinking in a very right way. Time does not make any sense to light because no information can reach light. So light will not see anything, light will not feel anything. Light is eternal. So manifold, Lalu, this is not the proper time to discuss about manifold. We'll discuss it later in a popular sense. Let's say configuration, geometry, and manifold. These two are very interesting thing you need to understand if you really want to understand what is going around, what is playing around. So manifold, I am taking it mind. Satoki, your question, I am not that expert, but I would say that you are very right in asking that in randomness the causality is not there. It should be there, but random event exactly in quantum world we don't understand, or I say I don't understand. I am not that expert to comment on the whole physics community, but as far as I understand, in quantum world we don't have any causality relation that okay, this state has been collapsed in this state because of this thing. I'm trying to make myself more clear. In quantum mechanics, we experience many random events. And in a cumulative way, we are seeing a macroscopic observation. But inside that macroscopic observation, we have many random events. But what causing the random events? It is the core question of foundations of quantum mechanics, and we still don't have the answer. There is a group of physicists who actually challenges quantum mechanics still today. One of them is Lee Smolin. He in his book he directly asked that question and told once again that quantum mechanics guys does not understand that what is causing your randomness, and we don't actually explain randomness. So as much as my understanding is stopped here, and if you want to discuss me or sharing some materials with me, if you have my number, you just message me. I think you are my own old Satoki, I guess. So we just have a chat in separate time. See, mathematical tools, these will hunt you every time. So don't spend too much on doing mathematics. You will learn mathematics. That is not a problem. But you first need to understand what is the basic postulates and what is actually happening. That okay, sir, a mass. Why this correspondence principle? What is this correspondence principle is actually telling about? And these field equations and tensor and this contravariance, covariance, these things, if you just write it 5 times, you will understand. That is not a problem. All physics students, my advice will always be See, if the mathematical structure is giving you problem, you just write it down 2 3 4 5 times, as I did. So you will understand that. Synthesis time dilation, I didn't discuss it. Why time dilation happens. I just told you that okay, time dilation happens. And if you want to know why this time dilation happens, I would say that we don't know. See, every physicist, if you ask to the very core, they will refer you to a postulate. So if you ask me that why this happens, why that happened, why that happened, I will always say, okay, go to Einstein basic postulate of special theory of relativity and general theory of relativity. If these are true, then these are true. That means if the basic two postulates of time special relativity, which is the first postulate, is you all know that the laws of physics are same as in every reference frame. So if you have an inertial frame here, inertial frame of course, if you have an inertial frame here, the laws of physics are same if you have another inertial frame somewhere else. And what defines this two inertial frame? They are moving with a constant relative velocity, not in a they don't have any relative acceleration. I think you understand the meaning of inertial frame. So laws of physics are same in two inertial frames. This is okay. And the speed of light is same in all inertial frames. That means essentially means the superiority of Maxwell equations. Superiority of Maxwell equation over Galilean classical world or Newtonian classical world. And if we accept that, then you will have all time dilation and length contraction, etc., etc. So that is the core philosophical idea. And the mathematical proof, it's just 5 to 10 lines of proofs given in books. But you need to first accept that Einstein postulates are true. Then everything follows from there. So Debojyoti saying, was there any time before Big Bang? Then we'll discuss in class 2 or 3. It's this lecture series episode 2 or 3. There are two explanations. There are two theories. One theory tell you that there was no time born at Big Bang. Another theory tell no, time flows at Kala Chakra. In my beginning is my end. As you see in my poster, I placed infinity symbol. This is not exactly infinity. I imagine this as a Kala Chakra. So we'll discuss later. Gravitation is Einstein's. Newtonian gravity, we rejected that. We came far beyond Newtonian gravity. So no confusion on that. Gravity is Einstein's gravity, beautiful theory of general relativity, beautiful theory of space-time. So Newton gave us a mathematical law which is very good, which is 100% correct law, that the force is gm1 m2 by r square. But Newton thought about it, that why two mass attracts, why two mass should attract. They don't touch nowhere, they do touch. They don't interchange anything between them. Newton thought about it, that if Sun and Earth is not interacting in any sense, they are not exchanging anything among themselves, then why should they attract? So there then comes Einstein, who gave us a theory. That theory you'll slowly understand. Understanding GTR is not a one day or one semester job. I'm still trying to understand GTR, so even after 10 years or 12 years has been passed, so you will slowly understand. So if you just compare which theory I need to reject, you reject Newton's. I mean, you just take Newton's equation, if gm1 m2 by r square. But you have to understand the space-time curvature matter. Any more question, any more intriguing question? That's why I make it a live discussion, because otherwise I just would have made a video and upload that. I will try to discuss among you, discuss with you guys every time. And if you have any question later also, you can just send me a WhatsApp. If there is a Kal Chakra, why it has a starting point like Big Bang? It should be a loop, no start and no end. That is exactly Sir Roger Penrose says. This is exact sentence that Robert Roger Penrose theory is. Cycles of time. He says there is no starting and no end. But not everyone accept that. Still, the general standard model of cosmology is the proper theory that time started at Big Bang. But Penrose theory is the exact classical Indian theory of Kal Chakra, classical Indian philosophy of Kal Chakra. It is exactly what Sir Roger Penrose says. There is no starting and no end. But we don't have a mathematical proof of it yet. We don't have. You need to understand that this Penrose cycle of time theory does not have experimental validation till now. Penrose is a great physicist, but in physics you understand that any theory has to be experimentally validated. Ashok Sen's string theory does not have experimental validation till today. Neither do quantum gravity have experimental validation till today. So only time will tell which theory is true. So if you have any more question, you can ask me later also. Or if you want me to discuss something more, you can. I really enjoyed in your questions. I enjoyed your questions. So I think we need to leave right now. Next, I see next Thursday, of course, or if that is 25th, then I will see what we can do. If I am free in Sunday, I can make an arrangement on Sunday 8 p.m. also. I will make everyone informed. Okay, guys, still 10 people are there online. So thank you very much. Thank you all the other guys which were there. Have a very good night. Have a very good night. We'll try to discuss many more things once in a week, let's say. Thank you so much, guys. Good night. Good night.